switches in all their glory. Here we go. So, before we dive into all the cool hardware that runs on a switch, let's talk about how you're going to configure the switch. And let me go ahead and just introduce Cisco Internetwork Operating System, okay? And network operating systems in general, they're a lot different than the operating systems that runs on your computer, whether you have a Mac and you're running Mac OS, or if you're running like OS X or whatever it is nowadays, or you have a Windows PC and you're running Windows 7, 8, 10, right? 9, just kidding. They're all there to accept user commands and then perform those user commands using the available resources of the device. So whether that's a computer, a router, a switch, AP, whatever it is, they all need an operating system that tells the device how to function, accept commands, and be manageable by users. Okay, so Cisco iOS is no different. There is a lot of key difference where Windows 10 may be like 7 gigs or something like that to run Windows 10. I don't know how many it is. It might be 3.5 or 4. It's excessive. It's definitely not Windows 3.1. Well, on routers and switches, we don't need anything for a great user experience for gaming or any type of multimedia, anything really. All we care to do is configure the settings that will allow the network to perform optimally and securely. Okay, so what that means is the iOS that we use on routers and switches, we're not doing any type of graphical user interface, right? We're using console interface, terminals. We are using command syntax, basically just text to configure the device. Okay, and Cisco iOS gives us a lot of help with that. Okay, we have context sensitive help. So if you know a show command, if you do show and question mark, it'll show you all of the available other commands you can put right after show. And it'll kind of lead you through the command until you complete it, right? It has, features for remote management. So once you've configured the box, okay, and you've done the initial settings, you give it an IP address, you give it a couple security things, then we can manage that network device remotely, okay? And Cisco iOS has been around forever, and not entirely forever, but since Cisco, and it does a very good job. One of the things that always intrigued me about Cisco whenever I started my career with GE, I would go and install some of their routers in a couple schools, and then it would be like 3 or 4 years later, I would come back and do the upgrade for the school, and looking at the router, I would see that the last time it was touched was the day I was there before, configuring it 4 years earlier. 4 years of uptime without a crash. I don't know what other types of devices can do that. You think about Windows or Mac, they go through updates every week almost. Mac's a little bit longer, but still, you're not going to see 4 years go by with zero fail, right? So that was always intriguing to me, and that tells us that we're only caring about the basic functions of the box, okay? We want to configure the device to do what it does, but we don't need anything sleek or sexy to do it. We just want to make it work, and we want the uptime there, and we want the security, and those are the important functions. Now, Cisco iOS, here's the thing. Even though there's different variants of iOS, there's a pretty common command structure for all of the Cisco devices. Sometimes, it gets a little hairy, but once you kind of learn how to work with Cisco iOS, you'll be prepared to work with all the Cisco Catalyst switches, all of the Cisco integrated services routers, and you'll have a good foot in the door for any of the other network devices out there, like the adaptive security appliances, the data center Nexus stuff. There's some differences with that, but bottom line is once you start learning a network operating system, you can quickly start working your way through other network operating systems. I remember one time I configured these BroadSoft Acme Packet session border controllers, okay, and I had to use a terminal to do that. I hadn't touched that before, but it was a very common and just familiar feel to it because I had had so much time configuring Cisco iOS routers and switches. All right, so with that being said, we're going to look at that more as we go forward, okay? Now, let's talk about the switch hardware itself. So, as we see, switches have a pretty distinctive form factor, okay? Typically, they're going to be in a 1U device for a simple access switch, but they could be all the way up to a 10U or even higher sometimes. And whenever I say U, I'm talking about the number of slots in a rack, right? So if you think about a normal 42U rack, it can hold 42 1U devices, and so this image here would take up 4 slots on that 42U rack. Okay, so they can expand from just 1U, and it depends on how many ports I need, right? So, and they can go all the way up to stacks. I mean, I've literally installed switches where we've got racks and a wall just of switches like this. Now, they come in a lot of different form factors. Okay, that's what you need to know. So you can get everything from like a little small 4-port switch all the way up to a switch with 100 ports on it. They have them. The speed is going to be one of the determining things. So what port speed do I need to provide? To my end users. Okay, those are the access interfaces on the switches. That's this stuff here. That's the access face on this type of switch. Okay, these are access interfaces. This one's 48, this one's 24, 48, 24. It's kind of a weird way to stack it, but hey, whatever. But there's also uplink speed you have to consider too. Okay, so the uplink speed is either here for traditional uplinks, and then some switches also have stacking capabilities where you can stack them together. Okay, and what that means, gives you all kinds of new switching functionality. So we'll talk about that in a minute. I don't want to jump there, but we want to understand that each switch port is going to be a solid speed once it comes up, meaning that it's not going to be a variable like Wi-Fi. Okay, Wi-Fi, as I get further away from the AP, I'm going to throttle down the data rate. Okay, or I get interference, things like that. With switches, once the port's up at 10 megs or 100 megs or a gigabit, it's going to stay there. So one of the ways that I choose to purchase switches is based off the port speed I need to provide the end users, and these are via the access interfaces. The other reason that makes me choose a certain switch is the uplink capabilities of the switch. Is it through the traditional uplink ports? Is it stackable? Is it both? Right? Those are good questions to ask. The other thing that is very common with switches is power over Ethernet, where we're actually powering devices through each switch port, like an IP phone, access points, digital media players, all that kind of good stuff, right? And nowadays we're doing quite a bit of power through each port. Now, one thing you got to know about the operation of the switches, because that's really what we were kind of showing here, is switches auto everything from the factory. Okay, so they auto negotiate everything. What that means is each access interface, okay, and actually all interfaces, they're going to auto detect the speed. Okay, which means if I plug in, let's just say I plug in a device, these are gigabit capable switches, and I plug in this device, it's a client PC, and it only has a 100 meg connection on this side. Well, the switch would auto detect that, and I would be brought up as a 100 meg interface basically. But let's say over here I've got a new, more powerful computer, and it's got a gigabit link. Well, the switch would auto detect that, and I would have a 1 gig link there, right? And then I detect also, switches will auto detect what's called duplex, meaning am I sending full duplex where I transmit and receive at the same speed. So if you have a 100 meg port, that means you can transmit at 100 megs and you can receive at 100 megs on that same cable. That's what full duplex means. Okay, if you're half duplex, that means I can transmit at this data rate, but I can only transmit or receive, but not simultaneously. Half duplex is old technology with wired networking. Okay, so half duplex was whenever we had hubs. All right, so if you remember our hubs, layer 1 dumb devices, okay, they repeat the signal that is transmitted by a machine. Well, because they're repeaters and they repeat every frame that's brought to them, they can only transmit or receive, but not simultaneously. That's one of the big benefits that switches gave us, okay, is full duplex connectivity. I can simultaneously talk and listen And then depending on the capabilities of my network interface and the capabilities of the switch port, I would choose which speed I can connect at. Okay. Now the other thing that switches do with each access interface, and really all interfaces, I keep saying access, and remember these are our access, these are our uplinks. They can really be used for anything. That's a moot point right now, but they auto detect mode. Okay, so the mode could be dynamic, access, or trunk. Now by default, switches are going to auto everything, so they're going to try to determine, is this a computer that's plugged in here, or is it another network device that I might need to set up a trunk with? Now, we haven't talked about trunking yet. We'll do that in the future. Okay, just know that switches auto try to determine that, right? I'm not a big fan of that feature, by the way. I don't like switches to auto determine mode. I don't mind them, and I prefer them to auto detect speed and duplex, okay? And even MDX, okay? Now MDX goes back to what I was saying earlier, where switches can now detect if I'm using a straight through cable or a crossover cable. Sorry. So straight through cable, remember, if I was connecting similar devices, as we said earlier, we typically would use a crossover cable. But switches can auto detect that, and they can auto make the crossover if they need to for us. So they're very capable whenever it comes to that. All right. So this is the basics of the switch operation. Like I said, they can auto speed, auto duplex, they'll auto mode. We'll talk more about that mode thing later. And then they can auto detect the cable type that you're plugging into them. And again, switches have been extremely important to the evolution of technology. They've allowed us to communicate at extremely fast data rates. Now, I mentioned that all wired networking is full duplex while we're on this page. All wireless networking, on the other hand, is half duplex still. No matter how fast that we say Wi-Fi is, as of today, we're still only doing half duplex, which means one station transmit, one station receive, but not simultaneously. Okay? Wi-Fi is like a walkie-talkie, but a very, very fast walkie-talkie. Okay? We got a whole module coming up on Wi-Fi, so stay tuned for that. All right. So in the end of switches, back in the day, early switches had all types of lighting all over them, okay? And it just got crazy to look at. It looks like Christmas trees, right? Especially if the switch is busy, you got lots of traffic, or if you accidentally created a loop, especially, lights would be going off like crazy, okay? But what Cisco did is they said, look, we're going to give you one LED per port, okay, because we want to be able to physically see what the switch is doing sometimes. Now, most of the switch's life after setup is in a closet somewhere, and you're definitely not looking at it, okay? But whenever trouble arises, you do want to have visibility into the physical status of something. So, on the front of every switch port, there is an LED. You can see that's for port 1 right there. Let me change my color. You can see right there, that's for port 1, and that's for port 2. So we go 1, 2, 3, 4, 5, 6. By the way, whenever you're looking at port numbering, that's the way it goes. Okay? All right, so you only have one LED, but I might need to see, A, is the link up, B, is it full duplex, C, is what speed is it at? Is it at 10 megs, 100 megs, or gigabit? And then D, is there PoE? So Cisco put this mode button on the front of the switches. Whenever I hit this mode button, that toggles the lights for the ports. So if I want to see which ports are operating at full duplex, I keep hitting the mode button until this LED lights up. Now, once that LED lights up, any of the link lights that are still green shows that those are full duplex. Any lights that are off are half duplex. Okay? So, then you've got the speed. So, any lights that stay on, are the higher speed. Any lights that are off are the lower speed. If I toggle the mode down to PoE, it shows me real quick which ports are actually drawing power from the switch, which is very, very useful. Okay? So this is how they do that and keep it with very low LEDs above the ports. and it makes it for a much cleaner visual inspection of the switch. So once you get a new switch out of the box, the cool thing is, if I go and I plug it into power, you notice, hey, there's not a power switch on most switches, okay? Especially these 1U access switches, there's no power switch on them. Why? Because they are designed to run 24/7, 365. Okay, that's their design. Now, some of the larger chassis switches that I'm sure you've seen before, if not, you'll see in a little bit. Some of these larger whoops, shouldn't have drawn that far. Some of these larger chassis switches that have blades in them, okay, that actually have anywhere between 2U of blades and like 12U. There was definitely a 6509s that we used to deploy all the time, which had 9 blades. Now, these have these power supplies in there, and only switches like this have power switches, and that's to be able to change the power supply. So you can turn on or off the power supply, but the switch is still designed for 24/7, 365 operation, because that is my link to the network. I can't route, I can't do anything unless I have a good link. So switches are designed for 24/7 by 365 operation. Okay, and only the larger switches, their power supplies actually, not the switch, will have a power switch typically, because they're not designed to be powered off. All right, so how do we power on the switch? We plug in the power cable. In the back of every switch, you're going to see a one or more power supplies. Okay, so I plug in those power supplies, the switch turns on instantly, and then it's going to start a process, and you need to become familiar with this process. Okay, the first process it's going to do is called post. Power on self-test. That's a hardware low-level test. It's going to check fans, it's going to check temperature, it's going to check interfaces, it's going to check all those internal components, memory, things like that, flash. And then it's going to, the second step is it's going to find and load the Cisco iOS software. So after it completes post, which is the power on self-test, then it's going to try to look for the Cisco iOS software. Now, there's a low-level code that's on every device that does that post test. So the iOS software was not required to do the post test. It's this other low-level code we call bootstrap code. Okay. Now, once we find and load the Cisco iOS software, then the switch is going to be ready to run. Okay, that's step 2, where we find the Cisco iOS software. The next step is to look for the configuration. Okay, so the configuration of a Cisco iOS device is just a text file. It's a very small text file that is located in a place typically called NVRAM. Okay, non-volatile memory. Let me go back here 1 second. So it's typically located in NVRAM. Now, if there is a configuration file located in NVRAM, that means that the device has been configured at least once before, because that's where we save the configuration to. If the device has not been configured for, then it would load a setup routine where you basically go through the initial setup of the switch. You're going to see this in the lab here in a minute. Okay. Now, that's why we said configuration is loaded into RAM if one exists. Notice we grab the text file from NVRAM and we load it into RAM, which is random accessible memory that runs at real time. Okay. So if we don't find a configuration file that's been saved in NVRAM, and then optionally another couple places we could put the configuration files, the mainstream practice is to use NVRAM, by the way, but you'll see later there's other places to potentially grab both the iOS and NVRAM if necessary. Then if we have that config file, we load it into RAM and the device is running with that configuration. Now, if we did not find the configuration file in NVRAM or another location, network location, then we run this setup routine. Okay, and you'll start to configure the switch. It's going to say, would you like to configure the switch? And if you say yes, it's going to start you and say, hey, give it a host name, give me an IP address, give me a mask, give me a gateway, you know, all that basic stuff so you can set up initial management. Give me a password, right? We'll show you the setup routine, but you guys will be able to set up a switch and you know, the basic configuration of a switch in about a minute once you're done with this program. Okay, so this is the process for a Cisco iOS device to boot, and you need to remember this because this will be on your CCNA exam. It also a network device booting and its process that it goes through could be on the Network Plus exam. It wouldn't probably be Cisco specific, but I would imagine the process is important to understand for that exam as well, if I remember correctly. All right, so switch auto setup. If the NVRAM or the startup config is what it's called, whenever there's a configuration that's in NVRAM, that's called our startup config. Okay, so because whenever the device boots, that's where it grabs a configuration to load into RAM. Okay, now if one is not found, if you've let's say you sold the switch and you're about to put it on eBay, you would delete the VLAN.dat file from Flash, which we'll talk about later, and you would do a write erase, which would clear out NVRAM, which means it would reboot and load setup configuration, right? Or if you got a new switch out of the box, it's going to start this auto setup routine. Okay, now this is called auto configuration, and it's going to guide you through the basic configuration of a Cisco switch or router. You set up passwords, you save it, and then once you save it, you can remotely manage the device, and you know, you can log into the device and all that kind of stuff. So it's just a very basic config. We're going to walk through this in a moment in our lab environment. Now, my goal with this program, I want to show you a couple different lab environments, but one that we're going to be using, and we'll have a special video on how to set it up and stuff like that, is now free to use, is called Cisco Packet Tracer. Okay, so let's take a look at this at Packet Tracer. And I'll bring this app right into view if a little bit of it's going crazy on me. All right, so what we want to do is come down here to the bottom, and in this lab we're just going to see the setup mode of the switch, right? So all we got to do is come down here to the bottom of our topology, select switches. It's already on network devices. We're going to grab this 3650 and drop it. The 3650 is the most recent switch. It's multi-layer, which we're not going to talk about right now. We're just doing the initial setup, but it's a very recent switch to use. You might even have some at your company. So if you click on this 3560, the first thing you'll notice that I like about Packet Tracer is it doesn't come with integrated power supplies. You actually have to add them, which is pretty cool. So if you want to see the front of the switch, it's got a really nice image there. It shows you that we've got the 24 port version. We've got 3 fans in. Those are modular too, so if one goes out, you can quickly replace them, pop in a new one. And we've got our power supplies down here. So we're going to drag 1 and drag 2. And as soon as we put those power supplies in, notice there's no power switch. We can click CLI and see everything booting. Okay, so you can see it's booting that full image into memory, and then voila. So the iOS is running. You can see it's a Cisco 3650 24PS. The processor board ID, we've got the serial number there, got the base Ethernet MAC address. So we've got some really good stuff. We also see the amount of memory we have there, and we're good to go. So there's our setup. Okay, it says, would you like to enter the initial configuration dialog? So we're just going to choose yes. Now, it says, basic management setup configures only enough connectivity for management of the system. Would you like to configure each interface on the system? No, we don't want to do that. So we want to do basic management setup. Yes. All right, so host name. Let's call this switch 1. And then it says, all right, you're going to need an enable secret password. Now we'll talk more about this enable secret stuff later, but there's a couple different modes in Cisco iOS that we're going to go over actually in another module, but there is user mode and then there's privileged exec mode. This password will protect people from getting able to make any changes on the device, right? So this password is what allows you to secure the device so people can't just make configuration changes. So we're going to make this Cisco 123 with a capital C. And it says enable password is used when you do not specify an enable secret password. And would you like to use an enable password? It is redundant to have both, but we're going to go ahead and put Cisco 123. It might yell at me because you're not supposed to use the same password for enable secret and enable password. So we're just going to use lowercase Cisco 123. Now it says the virtual terminal password is used to protect access to the switch or router over a network interface. So these virtual terminal lines allow us to remotely connect to the switch or a router without having that console cable, right? If we were at the switch right now to get to this terminal in a real switch, we'd have to be using that console cable we talked about earlier. And we'd have to be physically standing there. So by putting on an IP address and by giving it a VTY password, we can connect to it over the IP address and do a virtual terminal console that way. So we're going to go ahead and give it Cisco 123, capital C. And it says, would you like to configure SNMP network management? Right now we're going to say no. There's all of our interfaces, right? And it says, would you like to use an interface name to connect to the management network from the interfaces above? So what are we going to use to configure as a management network? Well, this has a couple of options actually. In a real 3560, there's actually a manager port specifically designed on the box for management. It's in the back of the switch in the back corner. In fact, let me see if I can show you. There we go. So you see this blue port here, that's the console interface on the back of the switch. But that yellow port is actually a manager interface. Okay, so if we scroll up here, I don't think it's showing us in the config. Now what we typically do is just use the native VLAN on the switch. So in our case it's going to be VLAN 1. We're going to talk more about VLANs later, but we're just going to use VLAN 1 as the default manager for now. So configure an IP address for this interface. If we're going to connect remotely, we need it. So we're going to choose yes. And the IP address for this interface, we'll just give it 192.168.0.5. Subnet mask, it's saying 255.255.255.0, that's fine. So we're going to just choose OK. And then it says enter selection. Do we want to go to the iOS command prompt without saving the file? Do we want to return to setup without saving this config, or save this configuration to NVRAM and exit? So if you noticed, we didn't give any of the other IPs an interface. It kind of gives us the display of what configuration we just did. So we have the host name, we have an enable secret password. It's already hashed that for us, so onlookers wouldn't know what we typed. The enable password, notice, is in clear text, so we'll talk about that later. Then we've got our interface VLAN 1. Right now it's shut down, or sorry, no shut. So that's the VLAN 1 would be up. And we've got our IP address of 192.168.0.5 on there. So we're going to save this. So hit 2, save, and voila, we've done the initial setup of a switch.